Hi guys, today is Monday, April 27th, subtracting integers. We are going to talk about subtracting integers, so I need you to take out your composition notebook and make sure you guys are taking notes and following along. Today's I can statement is I can subtract positive and negative integers with two color counters. At any point during the PowerPoint presentation, if you guys need to pause the video, please do so and take notes. All right, so let's recap from next week or last week. We did addition, as you guys notice here. We had scenarios if signs were the same when we were adding, meaning we're adding a positive number and a positive number, or we were adding a negative and a negative number. We ended up adding and keeping the sign the same. You can see at these two examples, 2 and 3 are both positive. So when you add them, you kept the sign positive and you added 2 and 3, 5. And then if the signs were the same, if they were both negative, it would be a negative and you'd add 2 and 3, so -5. Same with if the signs were different. If the signs were different, you ended up subtracting them and using the sign of the larger absolute value. So again, last week we added like and unlike signs with two color counters, number lines, and using the rule as our example. So we just covered the rule. This week we're going to be doing the same thing, but we are going to be subtracting integers with like and unlike signs. So we're going to use the same strategies as we did last week for subtracting integers, and today we're just going to focus on two color counters. And if you guys notice to the left, I actually have the rule here, and we'll practice more with this as we go. But if you guys ever hear me say add the opposite, it's because we're trying to make this subtraction problem into an addition problem. So if you guys watched this video, it is the activation strategy. So hopefully you already watched it, but let's go ahead and talk about a couple examples. So here is our first example. We have types of subtraction problems that I kind of want to break down for you guys. So here we have a positive number minus a positive number. So if you notice 8, guys, 8 is positive and so is 5, and we are subtracting these two. But 8 is larger than 5. Notice number 2, 5 is not larger than 8, so that's going to change our answer. So let me show you with two kind of colored counters how that's going to look. We'll start with 8. So I have 8 positive counters. Sorry, I don't draw the best circles, so I'll do my best. So I have 8 color counters. 6, 7, 8. And we want to take away 5 positive counters. And we actually have enough to take away, so I'll just take away 5. And what you're left with, guys, is actually your answer. I'm left with 3 green counters, so my answer is actually +3. All right, let's look at number 2. So number 1 was pretty straightforward. That's something that you guys all know. Number 2, we start with 5 green counters. And now we want to take away 8 green counters. However, here's the problem. We only have 5. So we need to add enough green counters to take away 8. So since I already have 5, I need to add 3 more green counters. However, we can't just add 3 green counters. We have to add 3 zero pairs. So if you guys remember from last week, a zero pair is 1 positive green counter and 1 negative red counter. So if you guys look here, my value is still +5 because I have a 1 zero pair, which equals 0. So I'm going to add 2 more zero pairs in order to have 8 green counters present. Okay. Now, since I have 8 green counters present, I can now take away 8 green counters. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. What you're left with is your answer. Whoopsies. Let me erase that. So I'm left with 3 green counters. I'm sorry, 3 red counters. So my answer is actually -3. So notice how your order actually matters. I had positive 3 for number 1 and negative 3 for number 2. All right, let's look at number 3. We have two scenarios. We can have a positive number, as we have in number 3, and we're going to subtract a negative number. So subtracting negative 4. So let's break this down using two color counters. I have 3 green counters, 2, 3, but I want to take away 4 red counters. However, I don't have 4 red counters present. That means I need to add 4 0 pairs. So I'm going to add 1, 2, 3, 4. Notice how we're adding the opposite. So I'm adding 4 0 pairs. Now, if you look at our problem, our value is still positive 3 because all of this equals 0. But I have 4 red ones that I can now take away. So that means I'm left with 7 green counters. So my value is positive 7. All right, let's look at number 4. What if we flipped? What if we had a negative minus a positive? So here I've got negative 4 minus positive 3. Again, guys, this is a subtraction sign. This doesn't mean that that 3 is negative. All right, so I'm going to go ahead and start. I have 4 red counters to begin with. And I want to take away 3 green counters. However, do you guys see 3 green counters? I do not. So that means we need to add 4 0 pairs. Or I'm sorry, 3 0 pairs. So I'm going to add 1, 2, 3. And I also need to add the red. 1, 2, 3. Okay, again, my value here is still negative 4 because this positive 3 and this negative 3, these together equal 0. But now I can actually take away positive 3. So when I take away these 3 green counters, I'm left with a total of 4 red ones and 3 red ones, which is negative 7 counters in total. Okay? All right, so here are our last types of problems. We have a negative number minus a negative number. And notice that I don't have 2 types of problems like this because negative 8 and I subtract negative 10, just like numbers 1 and 2, and 5 and 6 kind of mirror that because negative 10 minus negative 8, we just flip those, okay? So number 5, again, we have negative 8 minus 10. Number 6 is negative 10 minus negative 8. However, negative 8 is larger than negative 10. And in number 6, negative 10 is smaller than negative 8. So let's see what happens if we flip those around. So I'm going to start with 8 red counters. 1, 2, 3, 4, 5, 6, 7, 8. However, the problem is saying I want to take away 10 red ones. I don't have 10 red ones present. So how many 0 pairs would I need to add in order to have 10 red ones present? I'd need to add 2 more 0 pairs to have 10 red ones I can take away. So if I add 1, 2 green ones, and then 2 red ones, because it has to be a 0 pair, right? Here's a pair, and there's a pair. Now I can actually take away 10 red ones because I have 10 red ones present. So let's go ahead and do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means my answer is positive 2. All right, so let's try number 6. What if we flip-flop negative 10 and negative 8? So now we have negative 10 counters present. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now let's read the question. It says I want to take away 8 red counters. Do I have 8 red counters present? I do, so I can actually start taking them away. 1, 2, 3, 4, 5, 6, 7, 8. So I'm left with -2 as my answer. So guys, I hope that was helpful. I hope you were following along. If you would like, I suggest that you have 2 colored pencils. You can use red and blue, red and green, whatever works for you guys to try these. So here are 6 questions that mirror the 6 that I just did and the types of problems. Once you complete these 6, I want you guys to check yourself with the key below that I'm going to attach to eClass. If you have any questions, please comment on the activity feed or potentially join your teacher's Google Meet session. All right, when you are done checking the key, you will also practice IXL. I apologize, that should be N3. Okay. I want you to try to get a minimum of an 85. Again, your username is student number at North Gwinnett, and your password is Bulldogs.